This, in this question, we have to determine the ammeter reading when a voltage of V is equal to minus V naught sin omega naught t plus 2 V naught sin 2 omega naught t plus 3 V naught sin 3 omega naught t plus 4 V naught sin 4 omega naught t is applied. Okay, so this is the voltage that is applied here, and we need to find out the ammeter reading. Okay, in the question it is given that when a voltage of V naught sin omega naught t is applied, okay, a current of I naught is recorded in the ammeter. Now we have to determine the current, okay, that will be, the ammeter reading in terms of I naught when this particular voltage is applied. Okay, now we know that I is proportional to integral of voltage. Okay, we must be more familiar with V equal to L di by dt, right? So from this we can get to this equation. Now we will be making use of this particular equation, okay, to determine the value of current for each of these individual components. Okay, for each of these individual components we will be determining the current in terms of I naught, and from that we will be determining the net current in terms of I naught. Okay, now we know that, okay, this equation is given in the sense this will be the value of current. I naught will be the value of current when the voltage source is V naught sin omega naught t, and hence when the voltage is equal to minus V naught sin omega naught t, the value of current will be minus I naught. Okay, now what happens when a voltage of 2 V naught sin 2 omega naught t, okay, is applied? So what happens is, since I is proportional to integral of V dt, okay, so it will be proportional to the current. In this case will be proportional to the integral of, okay, will be proportional to integral of this particular voltage. Okay, since we have a 2 coefficient here, let us write this down. Okay, now when we integrate this, since there is a 2 here, factor of 2, the frequency is twice, okay, of the this particular factor. Okay, now since we integrate, this 2 will come here, okay, it will be divided. So this will be again proportional to I naught. Same will happen with 3 V naught sin omega naught t. We will have a current of I naught. Same with 4 V naught sin, it will be 4 omega naught t. So for all the components, the current will be equal to I naught. In this case it is minus I naught. Now we have to determine the current when this voltage is applied. Okay, since we are dealing with AC here, the current will be equal to the net of this current, in the sense since we are considering the RMS values here, so I will be equal to root of I naught square plus I naught square plus I naught square plus I naught square. Okay, that will come down to root of 4 I naught square is equal to 2 I naught. So when this voltage is applied, okay, the current that the ammeter will read is equal to 2 I naught. So the thing that is very important here is the proportionality of the current to the integral of voltage, and as a result of which, okay, whatever be the factor that is multiplied to the frequency will be divided, okay, should be divided to the factor that is multiplied to that is the coefficient of that particular voltage. So that is to be remembered here.